For hundreds of years, people imagined that the world was flat. Its true shape only came to light through the use of technological means. Our planet is round, but not completely spherical, however. Its shape is that of an ellipse, slightly flattened at the poles and slightly bulging at the equator. This unique shape of the Earth is described as geoid and was only discovered in the last few hundred years.
Number 10. All the other planets and stars we've ever seen are round, and there's no reason to indicate that the Earth should be any different. Number 9. Time zones. Day and night happen at different times at different places on Earth. In fact, it's always day somewhere and night somewhere else. Number 8. The Coriolis effect means freely moving things like cannonballs or hurricane winds are deflected to the right, but only if you're north of the equator. If you're south of the equator, they're deflected left. Number 7. Triangles. If you walk 10,000 kilometers straight along the Earth's surface, turn 90 degrees to your right, walk 10,000 kilometers more, turn right again, and walk another 10,000 kilometers, you'll be back to where you started, having successfully made a triangle with 3 90-degree angles. As any geometry student can tell you, this is impossible on a flat surface. Number 6. The sun, in general, gets lower and lower in the sky as you travel away from the equator, and you can use this to directly measure the Earth's curvature. Number 5. The stars at night change as you go north or south. For example, Orion is upside down if you're in Australia. Number 4. Ferdinand Magellan, and many people afterwards, circumnavigated the Earth. That means he left headed west, continued going west, and came back to where he started, still going west. Number 3. The horizon. Ships on the ocean or tall Chicago buildings viewed over Lake Michigan disappear bottom first, and you can see the sunset twice if you watch it lying down and then quickly stand up. The simple fact is, if the Earth were flat, there wouldn't be a horizon beyond which things could disappear, so from across Lake Michigan you'd be able to see all of Chicago, as well as the Rocky Mountains.
Ancient sailors came to understand this based on observing ships that sail over the horizon. A ship gradually disappears until the only thing visible is the tip of the mast. This means that the sea must curve down and away, and the Earth probably does too.
Number 2. During a lunar eclipse, the shadow of the Earth on the Moon is curved. And number 1. We know the Earth is round because we have photographic evidence.
In the 3rd century BC, the Greek astronomer and mathematician Eratosthenes was able to estimate the size of the Earth with surprising accuracy. Eratosthenes was the director of the Great Library of Alexandria in northern Egypt. In one of the papyrus scrolls in this library, he read an account from Siene in southern Egypt. It was observed that on June 21st, the longest day of the year, vertical objects cast no shadows. As the sun approached midday, the shadows from the temple columns grew shorter and shorter until they were entirely gone. In addition, the reflection of the sun could be seen in the water of a deep well. All this indicated that at that moment the sun was directly overhead. Eratosthenes tried to reproduce these results in Alexandria on June 21st, and found that there, vertical objects did cast shadows at noon. From this discrepancy, he concluded that the Earth must be curved. He first reasoned that the sun shone light on Siene and Alexandria at the same angle. Since the sun is so far away, only the light that is aimed directly at Earth will reach our relatively small planet. The specifically aimed light hits all of the Earth from essentially the same angle and can be considered parallel. Eratosthenes then imagined two columns of the same height, one at Alexandria and one at Cyane. If at any moment neither column cast a shadow, the sun must be directly overhead both, hitting them at the same angle. Even if they cast shadows of equal length, the sun would be shining on the right angle, formed by the columns in the ground, from the same inclination, a scenario only possible on a flat Earth. However, this was not the case. For the parallel rays of sun to be hitting the columns at different angles, the surface of the Earth must be curved. Eratosthenes reasoned that the greater the difference in shadow length, the greater the curvature of the Earth. From the length of the shadow and the height of the column, Eratosthenes calculated that in Alexandria on June 21st, the sun was shining at an angle of 7 degrees. Using Euclid's geometry of parallel lines, he deduced that if the columns at Alexandria and Cyane were continued underground, they would eventually meet at the exact center of the Earth at an angle of 7 degrees. Since the two cities were 7 degrees apart on the sphere of the Earth, the distance between them was about 1/50th the distance around the whole Earth. Eratosthenes hired a man to walk from Alexandria to Cyane and count his steps. This measurement showed the distance to be approximately 800 kilometers. With 7 degrees around the Earth measuring 800 kilometers, Eratosthenes calculated that a full 360-degree circumnavigation of the Earth would measure approximately 40,000 kilometers. This measurement, which is only 800 kilometers less than the Earth's true circumference, was made with simple observations and basic geometry nearly 17 centuries before the age of exploration and the first concise global maps.